When you start to think about the derivative of something as the slope at a certain point on a graph, it can conceptually make some more sense. For example, when relating speed, velocity, and acceleration, speed is how fast something is going at a constant rate and is a scalar quantity that has no direction. When you take the derivative of speed, you get the velocity of something. Velocity is also how fast something is moving at a constant rate, but it is a vector quantity and it has a direction. If you go one step further and take the derivative of velocity, you get acceleration, which tells you how fast something is speeding up at a certain rate or how fast something is slowing down, etc.
I'm not waiting for the green lights.
There is a common relationship between speed, velocity, and acceleration that labels the second derivative of speed as equivalent to the derivative of velocity and equivalent to acceleration. Thank you. That concludes our lesson for today.
Sigh, these nonlinear equations are driving me nuts. But I've got a solution: local linearity. You see, nonlinear equations can be hard to solve, but with local linearity, we can take a small section of the graph and approximate it with a linear equation. Ta-da! We have a linear equation that's a close approximation of the nonlinear equation in a small area. This part is an overestimate, and this would be an underestimate.
Dr. Linear, we need you. We're trying to find an estimate of this mountain slope, but it's non-linear.
I got just the thing for you.
By using a rough estimate for this mountain, I can get a slope of 1/2 feet, but that's an overestimate.
Oh, I see. Thank you, Dr. Linear. Good afternoon, students. In today's after-school study session, we'll be learning about indeterminate forms and L'Hopital's rule. Now, I know it sounds boring, but trust me, this topic is crucial to understanding calculus. Yes, Zachary?
Mr. Fang, I'm lost already. Can you give us an example?
Of course, Zach. Let's say we have a limit x squared divided by x minus 1 as x approaches 1. Now, when we plug in x equals 1, we get an indeterminate form of 0 over 0. Think of it like this, Zach. It's like trying to divide a pizza equally among 0 friends.
Hey, is that a roast? Oh, I get it. There's no way to divide it equally.
Exactly. That's where L'Hopital's rule comes in. Yes, Edmund?
Mr. Fang, what is L'Hopital's rule?
Huh?
L'Hopital's rule is a way to evaluate the limit of a function when it has an indeterminate form. It's like having a tiebreaker for dividing that pizza equally among your friends. Now let's see it in action. Using L'Hopital's rule, we can see that the limit of x squared minus 1 divided by x minus 1 as x approaches 1 is actually equal to 2.
Oh, that's cool, Mr. Fang.
I never knew math could be so delicious.
And that class is the power of indeterminate forms and L'Hopital's rules. In this video, I'm going to be teaching you how to solve this related rates problem here with our imagination. The first step is to draw a picture. A treasure hunter named Zach is searching for treasure 30 feet away from an escape ladder near a wall in a desert tomb. He observes another treasure hunter named Edmund who had just stolen a massive block of gold. Edmund begins climbing the ladder at 2 feet per second in order to escape the tomb. Wanting his treasures, Zach points his bow up and aims the arrow at Edmund's back. At the instant when Edmund is 10 feet up the ladder, how fast is the distance between the hunter and Edmund changing? From this drawing, we can see a right triangle. In this case, the Pythagorean theorem can be used to solve for y.
Golly, I can't wait to find some treasure in this ancient tomb.
Oh boy, I'm so glad I found this block of gold. I'm going to be rich.
Hey, give me that!
After drawing the picture and solving for y, you want to write an equation that relates all the variables in the problem. Just like the previous step, we can use the Pythagorean theorem.
Oh balls, a treasure hoarder. Scram, this gold's mine.
No, how about you, Scram, Stone?
Oh food!
Using the Pythagorean theorem, you want to take the derivative of both sides. And remember, don't forget the chain rule.
You will never get away, coward!
Once you take the derivative of both sides, plug in the known values and solve. The distance between Zach and Edmund is changing at 0.632 feet per second.
I win, you filthy swine!
So now you know how to answer related rates problems. So that is it for this video. Thanks for watching and have a great day.